Two companies can use the exact same AI model and still get very different results. They may subscribe to the same platform, run the same tools, and pay the same price for access. Yet one company becomes dramatically more effective while the other sees only modest improvements. At first glance, that seems strange. If the technology is identical, the outcomes should look similar. But in practice, the real advantage often has little to do with the model itself. Imagine two retail companies using the same AI forecasting tool to predict demand. Both feed the system historical sales data. Both receive recommendations about inventory and pricing. But one company has years of structured customer data, detailed supply chain records, and clean product information. The other has scattered spreadsheets, inconsistent records, and gaps in its historical data. The AI model is identical. The results are not. One company receives precise forecasts that can guide decisions. The other receives suggestions that feel unreliable. The difference comes from the surrounding system. This pattern is becoming more visible as AI tools spread. Early discussions about artificial intelligence often focused on the model itself. The assumption was simple: whoever had the best algorithm would gain the largest advantage. But as powerful models become widely accessible, that assumption becomes less reliable. When many organizations use similar tools, the real difference often lies elsewhere. One major factor is data. AI systems depend heavily on the information they receive. If the underlying data is structured, consistent, and detailed, the system can produce more useful outputs. If the data is fragmented or incomplete, the same model may struggle. This creates a quiet advantage for organizations that invested in strong data infrastructure long before AI became popular. They may not appear more advanced on the surface. They may even use the same tools as their competitors, but their inputs are stronger. Workflows also play a critical role. AI systems rarely operate alone. They interact with internal processes, databases, and human decision-making. Some organizations redesign workflows so that AI systems receive the right information at the right time. Others simply add AI tools on top of existing routines. The difference can be subtle but significant. When workflows align with the technology, recommendations become easier to use. When they do not, the system produces outputs that feel disconnected from daily operations. The tool exists, but its impact remains limited. There is a reasonable counterargument. Some people believe that increasingly powerful models will reduce the importance of data quality and internal systems. As models improve, they may compensate for messy data and imperfect workflows. There is some truth to this idea. Modern AI systems are far more tolerant of imperfect inputs than earlier technologies. But even the most advanced systems still depend on context. Clean data, reliable processes, and integration across systems remain powerful advantages. Integration is another factor. Some organizations connect AI systems directly to multiple internal tools and databases. Information flows continuously between departments and models. Other organizations use AI in a more isolated way. Teams upload documents manually or rely on limited datasets. The difference may not be visible from the outside, yet it significantly affects how much value the system can generate. Integration determines how much of the organization's knowledge the AI can actually use. These differences create second-order effects. When one company consistently receives better insights from AI systems, it begins to make slightly better decisions over time. Inventory planning improves. Marketing campaigns become more targeted. Customer service becomes more efficient. Each improvement may appear small, but over time they compound. Gradually, the company builds a reputation for stronger execution, even though its technology may look identical to competitors. The advantage accumulates quietly. This dynamic can reshape competition. If AI models become widely available, access to technology alone may not define leadership in an industry. Instead, advantage may depend on how effectively organizations organize their data, processes, and internal systems. Companies that invested early in digital infrastructure may discover that they are unexpectedly well-positioned. Others may find that simply adopting AI tools does not immediately transform performance. The surrounding system determines how much value the technology can create. Public discussions about AI often focus on breakthroughs in model capability. New models attract attention because they promise dramatic improvements. but the impact of those improvements may depend heavily on conditions inside organizations. Two companies can install the same system and experience very different outcomes. The difference lies not in the algorithm, but in the environment around it. Over time, this may lead to a quieter but persistent gap between organizations. Companies with strong data practices, integrated systems, and adaptable workflows may benefit from each new generation of AI tools. Others may struggle to capture the same gains, even while using the same technology. The gap grows slowly and often without obvious signals. It is not a difference in access. It is a difference in readiness. None of this means model capability is unimportant. Advances in AI still expand what organizations can do. But as these tools become more accessible, the focus of competition may shift. Instead of asking who has the best model, the more relevant question may become who has the best system around it. Because in the AI era, the hidden advantage is often not the tool itself. It is the infrastructure, data, and workflows that allow the tool to work well.